Okay, well, first of all, let me say that the first several sections of this book are going to be horribly boring because they are the most simple algebra terms and problems that you've ever had. But they're important to sort of get your brain thinking that way again. A lot of these things are going to show up on the ACT and the Coyote, so we still need to go over some of them. So for the first couple chapters, I'll probably be doing several sections in a video, so just watch it, go back, if you need to look at it again, whatever. But section 1.1 in your book is notation and symbols. And it starts by talking about variables, and basically it's just going to tell you that variables are a way to represent a number or something. And they even talk about using variables like your name represents you as a person. As you move on, though, in the next page, they've got this chart, and this is something that you need to make sure that you're completely familiar with. I was surprised last year at the amount of seniors who struggled with remembering what was less than, what was greater than. A lot of people didn't know what the not equal to sign was. So just go over this chart, make sure that you have this completely 100% memorized. It's one of those things that these first couple sections, knowing this chart and knowing what you're doing there will help you solve those more complex problems. It's the equivalent of, for example, trying to read a book in English and having to look at the dictionary to figure out what every word means. So make sure that you know those. The symbols down here, addition, subtraction, multiplication, division, no big deal. So let's move on and see what else we have. That's about it for section 1.1. Section 1.2 starts talking about real numbers. All right, and this is another thing that seems trivial, seems simple, but I was again surprised at the amount of people that struggled with addition and subtraction of positive and negative numbers. And so the way that I teach it and the way that I want you to think about it, unless it's so ingrained in you to think about it a different way, is a number line. Okay, so we all know that we have our number line that goes from negative numbers to positive numbers. All right, so what would happen is when I ask, especially my 1B kids is where this seems to show up most. I ask kids, let's add 5, let's do this problem right here. 5 plus negative 6. Okay, so in middle school, I guess they teach this keep, change, and all these different little tricks and stuff, and it drives me absolutely nuts, all right? So don't use keep, change. Throw it out the window. I hate it. Doesn't make any sense. What makes sense is the number line. If there's a plus sign or a negative, it's going to tell you whether you're going right or left. If there's a plus sign, I'm going to the right. If there's a minus sign, I'm going to the left, all right? So if I'm doing 5 plus negative 6, I'm going to start at positive 5, and then I'm going to add negative 6 to it. So I'm going negative 6, which means I'm going this way 6 units. This distance is 5 units. If I add one more to that, I end up right here. Okay? That point is obviously negative 1. So this is negative 1. And it's important that you know how to do this quickly and easily without the calculator, because again, when you get more complex problems, it's going to waste way too much time to put this in the calculator, and then God forbid you put it in wrong, so on. So use the number line, think of it that way, and it's going to make your life a whole lot easier. And they actually talk about it that way in the book. So they show you the number line, they show you the negative direction, the positive direction, everything like that. Let's see. Over here, they just give you the definition of a fraction. If we have two numbers, then the expression a over b is a fraction. And this is another issue. Sometimes I think people think of fractions as like completely separate, different things. So if I have a over b, these are just two numbers, right? If a equals 2 and b equals 3, then my fraction is 2/3. 2/3 is the same as 2 divided by 3 is the same as, however you want to write it, it's 2 divided by 3. And that is a number. So the next part of the book says that if I have a fraction, 2/3, I can multiply or divide both of these, top and bottom, by the same number, and it's not going to change the fraction. So let's say I multiply it by a 4. Okay? As long as I multiply the top and the bottom by 4, nothing's going to change. So I move this over, now I have 8/12. The question is, why is 8/12 the same as 2/3? If you go to your calculator, of course, and you put 2/3 and you put 8/12, you're going to get the same thing. Why is that the same? Well, the reason is this right here is a fraction itself. 4/4, if we reduce it, is 1/1, which is just 1. If I multiply anything by 1, I get the same result. So that's why we're able to do that. That's where simplifying fractions comes into play. I want to multiply it by something so that my denominator changes, but the value of the fraction stays the same. That's why I'm pick this number right here to multiply that by. I got a little off track. I'm sorry. Let's get back. So we come back now to absolute value and opposites. Okay, the absolute value, as you can see in the definition up there, the absolute value of a real number is its distance from 0 on the number line. So if x represents a real number, the absolute value of x is written as absolute value sine x. So basically, all the absolute value is the distance away from 0. And this is another elementary / middle school thing that gets people in trouble. If the absolute value is the distance from 0, so here's 0, this is 5, this is -5. In elementary school, this is about as far as you go. In middle school, this is about as far as you go. You say, what's the absolute value of 5? It's 5. What's the absolute value of -5? It's 5. So what happens is you get confused with that negative. And what happens, people think that no matter what, I always have to make this absolute value positive. It just automatically changes it. Stop thinking of it that way and think of it as that is the distance that number is away from 0 on the number line. If you think about it that way, it's going to make things a lot easier, because you're going to end up dealing with like absolute value inequalities later, and if you just try to make all the negatives positive, you're going to have incorrect answers. Next we have reciprocals and multiplication with fractions. So example 13 says to multiply 3/4 and 5/7. Remember that when you multiply fractions, you're going to multiply straight across the top. So we have 3 times 5 is 15, 4 times 7 is 28. So straight across, nothing tricky, no problems. The reciprocal of numbers, if you look down at the bottom of this page, we're on page 16 at this point. So reciprocals of numbers, basically you're just going to take that number and flip the fraction. So you write the number as a fraction. So the first example they give you is 5. So if I write 5 as a fraction, it's going to be 5/1. So the reciprocal of 5/1 is 1/5. Okay, this has nothing to do with positive, negative. That comes later. That's getting into your opposite reciprocals for slope of perpendicular lines. The reciprocal is just the fraction flipped. Okay, let's see what else we have. So that's going to get us through section 1.1 and 1.2. And again, these videos are basically just going to be a review. You should have seen all of this. I'm hoping that you remember a good majority of it. But look at this video. I hope it helps clear up some of those issues. You're going to look through the book, through the examples, through the chapter, actually read the words in the chapter, and then you're going to do the problem sets. So all of that's probably been explained by this point, but that'll get us through 1.1 and 1.2, and next video will be for 1.3 and 1.4.